Hi, my name is Ashok Modi, and today we are building an AI application for abstract image classification using convolutional neural networks that is inspired by the chapter 9 of Mr. Dennis Rothman's textbook Artificial Intelligence by Example. In the next slide, we can see that project folder and the path. So here I have assigned project name as AIC, that is a abstract image classification with CNN. This project is located into the Python 313 folder, and that folder has one dataset folder, image, and then 3 Python scripts. In the dataset, we have 4 subfolder called classify, model, test set, and training set. In model, we can see like the JSON and H5 files. However, in the test set and training set, we have 2 subfolders A and B, and each consists 10 images. So this is the actual folder where the file is located in the AIC. We will work on this image. In the dataset, we have subfolder, and in the subfolder, we have some images. Now let's start with the ideally. So here, first of all, we open the script. First of here we have 3 different Python script, and first of all we start with the edge detection kernel. So here you can see that when I run the script in our edge detection kernel file, a small 3 by 3 matrix called as a kernel slide across our image pixels to highlight the sharp changes in brightness. Now let's move to the second one file, that is a ReLU file. Let's run it. So ReLU is basically called as a rectified linear unit. In the ReLU simply turn all negative pixels value to the 0, which is introduced as a non-linearity. This allows the model to learn highly complex visual patterns instead of just straight lines. Now let's run the third and primary file, that is called zero CNN strategy model. So this is the main file where like we will import the model using the Keras and TensorFlow. In this file, we initialize the sequential, like this is the initialize sequential. The classifier would be the sequential. Here, as a part of the architecture, we have like a different steps where the file goes through. The first step is a convolutional. So here we define an explicit 64 by 64 input layer, and we take a 2D convolutional layer with 32 filters to catch edge, followed by the pooling layer to shrink the spatial dimensions and reduce the noise. We repeat this take to capture the higher level features. Next one is the flattering. So we flatten the 2D matrix into the 1D vector and feed it into the dense network. Then the final layer will use the sigmoid activation function, which output a single value between the 0 to 1, and that is the perfect for our binary classification. Later we'll use the image data generator to scale our pixel between the 0 to 1 and apply the data augmentation like shears and flips. And then it fit the model using the training and test set. Now let's run the script. Now here we run the script, and once trained, the script automatically export the model architecture to the JSON file and save the train weights. This allows us to load our abstract classifier into the apps instantly. Here we can clearly see that the model is the sequential and how the model is look like. It's in readable format. It found the 20 images what we have saved in the folder, both A and B, in the training set and the test set folders. Here we set the training to run for two epoch. Out of them, like a first one has an accuracy level is a 0.50, and the loss level is validation loss is 0.97. However, for the second one, the accuracy goes high is a 0.60, and the validation loss level goes down 0.94. And finally the model is saved to the disk. So the training process successfully returned, and the Keras history object for our classifier and the fully trained model is saved directly to the disk. Thank you.